Good morning, all. So let us start the next part. We are solving the problems in rectifiers. Already we have been solved so many questions. I hope you all understood the procedure. Do let me know. Am I audible? Just drop it in the comment section. Okay, I hope I'm audible. If there is any problem, just let me know. Okay. So let us start the session. Just text in the comment section if you have any problem. Okay. So we have completed the basics of electronics. We saw so many questions. We saw how to design gate pulse, why we are going up with the pulses, why we are not giving continuous current, and how to calculate that. Everything we have been discussed. Now we are in rectifiers. In rectifiers already we saw some basics, and we saw how to calculate the average values, RMS values when a circuit is given. Let us continue with the next question. So let me drop the first question here. So the first question given it is, let us take a single phase semi converter, a single phase semi converter. Just note down the question. A single phase semi converter is connected, given it is a single phase semi converter is connected to 120 voltage 50 hertz supply. This is the given. This is given, it is supply. Now what is the question is, suppose if it's feeding RLE load, it feeds RLE load. Okay, just read the question. RLE load, whereas the value of R is given as 6 ohm and the value of L is given as 6 millihenry and the value of battery E is given as 60 voltage. Everything is given already. Now the question is, the delay angle of the converter is pi by 3. The delay angle of the converter is pi upon 3. That is the given data. Okay, sir, everything is given. Then what is the question? The question is, input current distortion factor is dash. Input current distortion factor. Okay, that is basically represented. Distortion factor is dash. That is the question. Take your time. Take 2 to 3 minutes. Drop your answer in the comment section. Be active. Keep smile in your face. Don't what I can say, first try to understand the question, what they are asking, what is the procedure to calculate the distortion factor. First write down the formula. You know how to approach step by step. Don't collect the unwanted things. I always requested you all, ஒரு கொஷின் வந்து கொடுத்துருந்தாங்க அப்படின்னா, it doesn't matter whatever என்னென்ன டேட்டா கொடுத்துருக்காங்க அப்படிங்கிறத ஃபோக்கஸ் பண்ணாதீங்க. Just only focus on the question. Question means we are supposed to calculate only distortion factor. So what is the formula or what is the procedure to calculate the distortion factor? First write down that and then collect the required data from the question for that particular question. Question is distortion factor. What is the data that is required for the distortion factor? That is the only thing that you have to do. Question, they might have given so many things. So instead of collecting them all directly, first focus on the question, then try to substitute all the values, then bring out the answer. Okay, and keep smile in your face and be active. Do it rapidly and be conscious. Don't think about something in your mind. In your mind you might be thinking about some movies or some other stories, and your hand will be writing on the sheet. This kind of things will be wrong. Okay, don't do like that. Be conscious. Do it step by step, as fast as possible. One more thing also, I told you, if it is mandatory, then use the calculator. If it is mandatory, then write the steps on the note. If these things are not required, then directly do it by your brain. You know how to do mind calculations, so try to habituate it. If you adapt with the mind calculation, it will save your time. If you save your time, it will be helpful for you to solve more number of questions in the exam, such that you can be easily placed in the top rank. Okay, fine. Just follow it and drop your answer in the comment section. Already 2 minutes are gone. Anyone have the basic idea? Sorry guys. If you know the answer, sorry, if you found the answer, immediately drop it in the comment section. You might have derived these things already. Single phase semi-converter, when it is feeding orally load, what is the formula to calculate the input distortion factor? Just substitute the formula, you'll get the answer. Got the answer? I'm giving 1 more minute also, no issues, but try to drop the answer. It's your responsibility to keep the answer in the comment section. Anyone? 0.126. Good. Any other answer? Geeta. What about other people? Is there any other answer for this? Okay, it's time to solve the question by myself. See, it is not possible to derive everything here by myself. What I will do is I'm giving some things which are very important. If you take full converter and semi-converters, you know the difference. Full converter means it is fully designed with the help of only SCR. Semi-converter means partially. Suppose I'm designing one semi-converter. In that case, I might have taken two diodes, two SCR. So basically, semi-converter in the sense partially controlled. Some switches in the circuit can be controlled. Some switches in the circuit cannot be controlled. There is uncontrolled switches. So basically, that is the meaning of this semi-converter. So now, when you consider semi-converter and full converters, what you have to do is, if you don't know this, just learn the procedure how to calculate the distortion factor for any converters, any rectifiers generally. Okay, I'm writing the formula directly. So if you take semi converter and full converter, this question will be often asked in the examination. The distortion factor, what is the basic formula? If you go up with the semi converter, the basic formula is 2 into root 2 cosine of alpha upon 2 upon pi into pi minus alpha, keep them all under root. See, you might have seen these things in the notes that was shared by us. நம்ம ஒரு notes ஷேர் பண்ணிருந்தோம் இல்லையா, PDF notes, short notes. அதில் கூட இது இருக்கும், நீங்க check பண்ணிக்கலாம், right? Anyway, it's better to learn how to calculate it. If you go up with the full converter, that is very easy. In case of full converter, the distortion factor will become simply 2 into root 2 by pi only. It is independent of firing angle. Just observe here, it is independent of alpha in case of full converter. But if you go up with the semi converter, it is depending on the value of alpha. Now if you read the question, the value of alpha, it's already clearly mentioned that the delay angle of the converter is pi by 3. Delay means, suppose if I am having a sinusoidal waveform, the sinusoidal is started its journey at 0 degree itself. But in case of rectifier circuits, when we are designing the rectifier circuits with the help of SCRs, directly at 0 degree itself, we are not allowing the sinusoidal waveform. We will be giving some delay after some 30 degree, 45 degree only. We are providing what? We are allowing this waveform to let enter into what? To travel through the SCR. So the delay that will be provided by us is simply called firing angle. We are firing the SCR. Okay, sir. So the conclusion is delay angle is known as what? Firing angle only. That value is already clearly given. Now substitute the value of alpha equal to pi by 3. You will be coming up with the answer. At least drop your answer now. If you replace the alpha by pi by 3, what you will be getting? You people will be doing some small mistakes. Let me tell you. If you take cos alpha, see here, if you substitute alpha by pi by 3, we know the value of pi by 3 equal to what? Pi means 180 degree. 180 by 3 equal to 60 degree. 60 by 2 will be 30. So I can write like this, 2 into root 2. What is the value of cos 30? In case of cos of theta in degree only, but cos theta will give you radian value, equivalent radian value. If I'll substitute 30, we all know cos 30 will be root 3 by 2. I hope you all know this. In the denominator, if you observe, pi into pi minus, here I have to substitute directly radiant only, because here there is no conversion. Cos of theta will give you equivalent radiant value, but here I can't substitute degree because pi is radiant. Pi minus alpha should be in radiant, so I am directly substituting the value in radiant only. Now if you reduce this, pi minus pi by 3, what you will get? It will be equal to 2 pi by 3. Yes, sir. So now you can reduce. That's all. This 2 will be cancelling out. Root 3 into root 2 will become root 6. Here it will become pi into 2 pi by 3 whole power 1 by 2. Now if you reduce it further, root 6, pi into pi will become pi square. It will come out. Yes, sir. Then you will be, can I write like this? Root 2 by root 3. It can be further written as root 2 by root 3. And here, let us see. This root 6 can be written as, how will you write this? This can be written as root 3 into root 2. Right? In the denominator, already we have root 2 by root 3. Denominator of denominator will be numerator. So I can write further that root 3 will come to the numerator. Root 3, already one more root 3 is there in the numerator. That root 3 to root 3 will become 3. So where is root 2? Root 2 is cancelled because in the denominator we have one root 2. In the numerator we have one more root 2. They get cancelled each other. Finally, but pi is there. Don't leave pi. So 3 by pi. If you reduce, that's just to take the fraction between 3 by 5, you will coming up with the answer. First, to try to simplify the steps as much as possible, because when you are directly doing some big values in the calculator, sometimes you might forget some data, or it may lead to some wrong result answer when you are reducing the number of digits in fraction. நம்ம என்ன பண்ணுவோம், 0.738 something data வரும். You will be taking only 2 value. நீங்க further அப்படியே proceed பண்ணுவீங்க. So like that, when you are avoiding 3 or 4 digits in fraction, and if you are continuing further, it may leads to wrong answer. that answer might not be available in the option, because sometimes they will give you exactly correct answer, 100% accurate answer. In that case you might be in trouble. So it is better to go with the actual values. So while reducing this kind of steps, try to simplify the steps as simple as possible. At last you can put it into calculator if it is required, otherwise you can directly solve it by yourself. That's all. Fine, sir. So this is how we are solving. See, this 3 by pi also you can do it by yourself. How, sir? You know, it equivalent value is 22 by 7. Now, when this 7 go to the numerator, 7 times of 3 will become 21, 21 by 22. Now you can reduce it easily. 21 by 22. Now put 0.210. Calculate how many 22s are there. Do it by yourself. Slowly, slowly. Try to bring out the answer. Okay. So this is how we are solving the question. Do remember this. This factor is very important. 0.78. Good. 7 times of 22. 154. It should be. Is it correct? One minute, guys. I'm also doing. Nothing is there. Okay, I hope every one of you got the answer. So let us see. I'm getting 0.954 because 210. You have to check how many 22s are there in 210. Now I'm getting 9 times of 22. It will be 9 times of 2 will be 180. So 198 I'm getting. Yes, it is correct. Okay, fine. So I am getting 0.954. I don't know what you people are getting. Try to drop the correct answer. Okay, done. So now let us go ahead with the next question. I'm getting 0.955. Do it correct answer, because see, almost I have dropped everything. Slowly do it. See, how will you do the, while starting it may be little difficult. Let me tell you, put 0 point. I know it is 21. I'm putting one more 10 in the numerator such that it will become 0 point. Now see how many 22s are there in 210. How will you do that? First, to find out the number of 20s in 210. It is very easy. You can easily identify, sir, if I'll put 10 times of 20 will give you 200. But I can't go up with the 20 times of 2 because I have to check 2 also. 22. 10 times of 2 will give you 20. So if I will put 10 times of 22, it will give you 220. It is not possible. 10 times of 220, 10 times of 22 will give you 220. So I need one, I have to check under 210, not 220. So 10 times of 220 is not possible. 9 times of 220, 22 is possible. So 9 times of 22 means what you will be getting? You will be getting 198. So what is the remainder here? Remainder is 12. Again continue. How many 22s will come under this? Like that you have to, I think it will be 5. Right? So you can proceed like that. Such that you will be slowly getting close to the answer. Starting it might seems to be trouble. But slowly, slowly, slowly while solving. At last what will happen is automatically just by looking into the data your mind will do that and you will be dropping the question. These values are very small, but don't do everything in the calci. That habituation is wrong. Okay, fine. Chalo. Let us go ahead with the next question. Do remember these things, and in your free time try to learn how to calculate this data. I have already told you that from the starting itself it's better to learn it properly. Before starting the lecture I have told some factors to remember everything. Like see, let me start the next question. Next question what is given is a single phase. Once again, just collect the data. A single phase fully controlled, a single phase fully controlled bridge rectifier okay, fully fully controlled bridge rectifier is connected to RL load. I'm going to connect it with the RL load. Is connected to RL load. Okay, sir. Next, it is operated at a it is operated at a pi by 3 firing angle. It is operated at a pi by 3 firing angle. Pi by 3 or firing angle or delay angle, both are same, right? And fed from 110 voltage supply, 50 hertz frequency. This is AC supply. Now the question is the resistance part of the load is, see, it is RL load where the value of R is given as 10 ohm. It is given already. What is the average value of thyristor current? The question is the average value of the thyristor current is dash. Now you can take as usual 2 minutes, 2 to 3 minutes you can take. I'll be waiting. Drop your answer. Average value of thyristor current is dash. Good. Most of you guys did the answers for last question. Kanaka, Savita, Suhaina, Sadhana, Gauri Muttu, Geeta, Manivannan, Kalaivani. Very good. Just continue this spirit. Don't stop. See, I can directly type the question before coming to the lecture, before starting the classes. I know it will save some 5 to 10 minutes of our lecture, but I Geeta 4.95 ampere. Very good. Any other answer? Just keep trying. It doesn't matter whether you are getting correct answer or wrong answer. It doesn't matter. But you should travel in a correct way. இதுதான் ப்ரொசீஜர். நம்ம எப்படி வந்து ஆவரேஜ் அரிஸ்டர் கரண்ட்டை கால்குலேட் பண்றது, அந்த ப்ரொசீஜர்ல கிறிஸ்டல் கிளியரா இருக்கணும். Numerically, if you are doing any mistakes, it doesn't matter. We can rectify it. 4.95. Okay. Any other answer? Good. Slowly, you people are improving. I'm really very happy. Chitra 4.95. Very good. Any other? See, it's a simple question. So I just wanted to know, given it is fully controlled bridge rectifier, of course they are given RL load and firing angle is clearly given. Now it's time to estimate the average value of the thyristor current. Sadhana 3.46. Very good. Any other? Did everyone got the answer? 2.145. Sukumari, good. Take 1 more minute also. No issues. Just drop your answer. That is what I need. See, basically, it is the full bridge converter, right? Full bridge converter in the sense, if you are calculating the average current offered by the source, I hope that will be equal to the load, no? Load current and the current will be both same. What is given? Let me solve the question. Let me solve. Let us go ahead. Given it is a single phase fully controlled bridge converter. Yes, sir. How will you draw the waveform for the single phase fully controlled bridge converter? Suppose when the moment we are trying to pass a sinusoidal waveform from the input side, let me pass a sinusoidal waveform from the input side. Okay, sir. This is the sinusoidal waveform that we are passing from the input side. If you focus at the output side, what might have happened? Sir, it is fully controlled. Fully controlled means you know the circuit, how it will be looking like. How will you draw the circuit? Fully controlled converter means it will be having 4 switches basically, and 4 switches will be controlled by a firing angle alpha. A single firing angle will take the responsibility to control these switches. And in the output side, they have connected RL load. It is like this. Then what they did is they have taken one source simply. One terminal is connected here. Another one terminal will be connected here. This is the basic circuit. Now what will happen here? When the moment, try to learn how to draw the waveform first. When the moment we are giving positive supply, sinusoidal means it will be having two polarity. One is positive, another one is negative. First I am taking positive polarity. So upper is positive, lower is negative. Let me name the thyristor. We know upper legs will be named in odd number, lower legs will be named in even number. So T1, T3 just for the sequence, just to get the order. T1, T2, T3, T4. Okay, sir. Now see, when positive supply will be injected here, here it will become positive. Automatically opposite plate, that is cathode of the thyristor T1 will be negative. By default, if you observe thyristor T4, cathode terminal and anode terminal, cathode will be receiving positive, so anode will be automatically negative. Similarly, the another side of the supply is negative. That will be reflected here. Thyristor T3, it will be minus plus, it will be minus plus. Now, the chances, there are 4 thyristors who are all having the chances to turn on when we are giving firing angle. If you observe, thyristor T1 and T2 are satisfying one condition. One condition means we must apply anode voltage. If the anode voltage is greater than the value of cathode voltage, then condition number 1 is satisfied to turn on the SCR. That condition will be here. This condition is satisfied only in thyristor 1 and thyristor 2. If you observe, T1 and T2 are satisfying this condition. So T3 and T4 are failed to satisfy this condition. So we are not going to consider thyristor T3 and thyristor T4 in this first cycle. So thyristor T1 and T1 and T2 are satisfied with these conditions. Okay, sir. Then what is the second thing? We have to provide the firing angle. Delay angle must be provided for the thyristor T1 and T2 in order to turn on them. So till then, The supply voltage will be blocked by the thyristor. If you observe the output voltage will become 0 till firing angle will not be given to the thyristors. So firing angle already given in your question at 5 by 3. Pi by 3 means pi equal to 180. 180 by 3 if you give, if I will cancel it, you will be getting 60 degree. So if you put 60 degree here, so almost at pi by 3 we are firing the circuit. So till that point, remaining voltage will be blocked by the thyristor. So voltage, output voltage will be 0. After that, what will happen? Immediately when the moment you are giving the firing angle, alpha will become pi by 3. It indicate gate current is injected, gate current will become not equal to 0. So second condition also being satisfied here, thyristor T1 and T2 will turn on immediately. Once they turn on, then what will happen? They will be started allowing the waveform directly to the output side. Okay, sir. Till now, the waveform is 0. After that, how you can observe the waveform? Is it like whether it will follow the same input voltage? See, after 60 degree, whether it will simply follow the input voltage waveform or the waveform structure will be different. Here, what will happen is, if you observe the inductor, what is the nature of the inductor here? We know V is equal to L into di by dt. That is the inductor. Inductor will not allow instantaneous changes here. Okay, sir. But if you observe here, the rate of change in current with respect to time. So inductor will be continuously charging. Which one will be appear immediately across the inductor? Which one will not appear the inductor across the inductor? You know, basically inductor will show its moment of inertia only for current. Instantaneous changes will not be accepted in the value of current in case of inductor, but voltage will be accepted. Do you know inductor will accept instantaneous changes in the value of voltages? So till now the voltage will be 0. Immediately if you are firing the thyristors, then the total voltage of the supply will be dropped across the output, across the RL load. So this value of the voltage waveform, this waveform will be simply reflected across the output. It will be started from here somewhere and it will be traveling in the same structure. It will be following like your voltage. So input voltage will be reflected across the output. Voltage waveform will be reflected. What about the current, sir? This is not the case for the current because inductor will not accept the instantaneous current for instantaneous changes for the value of current. Inductor will be slowly accepting, slowly allowing the current to flow through it. But voltage can, you can allow, you can drop any value of voltage across the inductor at any time. Instantaneous changes will be happen for the voltage, but only current cannot be do that. Similarly, if you take capacitor, in case of capacitor, you can observe the instantaneous changes in the value of current in capacitor, but you cannot observe the instantaneous changes in the value of voltage because capacitor will show its moment of inertia in terms of voltage. It will be opposing the initial voltage. Slowly it will be accepting the value of the voltages given by you. Okay, sir. So the conclusion is inductor will not affect the waveform of the voltage, but if you observe the current waveform, the nature of the current waveform will be quite different. Different means what? Inductor will be charging basically. So inductor till now current flow through the thyristor is 0. Current flow through the thyristor is 0 because thyristor was acting as a open circuit till pi by 3. After that thyristor T1 and T2 will be turned on. We are giving firing angle pi by 3. Once it is turned on, then inductor will be slowly charging, reaching its maximum value till the end of the positive supply. After that, if you observe, polarity of the supply will get reversed at 180 degree. When the polarity will get reversed, immediately this reversed polarity will get reflected across the thyristors. So when the polarity will be reversed, now you have to once again cross check who are all having the possibility to turn on. Now focus on the second side. Second side means, sir, when the polarity of the supply will get reversed, this will become plus, this portion will become minus. Let me remove those things. Now, who is having the possibility to turn on? Who is not having the possibility to turn on? In case of RL circuit, there are few more things is required to notice. Let us see all those things one by one. Now, polarity of the supply is getting reversed here. So here it is become plus. Here also it will become plus. Opposite is going to be minus now. Similarly, here it is become minus. Here it is plus. Here also it is minus. Here it will be plus. If you observe carefully, thyristor T3 and T4 are satisfying condition number 1 according to the reversal of the supply. But what you have to observe, one more thing, what you observe here is this inductor is already stored a huge amount of energy from the positive supply. When the moment you are reversing the negative supply, only see in the negative at the moment of starting after 180 degree, the value of the negative voltage is very less when I am comparing it with the positive energy stored across the inductor, because the inductor is stored this much energy. See, this much energy is stored across the inductor, whereas the negative energy is very less. You are about to start negative energy, you are about to start injecting the negative energy. So when I am comparing the negative energy with the positive energy, the amount of positive energy that is stored across the inductor is quite higher than the value of the amount of negative energy given by the supply. So though the thyristor T3 and T4 are satisfying the condition number 1, like anode voltage will become greater than cathode voltage, when we are comparing that voltage with the inductor voltage, now what will happen is inductor is already fully charged. When the moment you are charging the inductor is acting as a load, so current entering point will be plus, leaving point is minus, where an inductor is charging. When the moment it is started discharging, when it is acting as a source, discharging in the sense he is trying to deliver the energy that was already stored by himself. When it is trying to deliver the energy, it is acting as a source. When it is acting as a source, then current entering point should be minus, leaving point should be plus. Guys, remember one more thing: for the inductor you can reverse the polarity, but you cannot reverse the direction of the current. Do remember this. Similarly, for the capacitor, you can reverse the direction of the current, but you must not reverse the uh, sorry, you must, one minute. For the capacitor, you can reverse the polarity of the voltage, but you must not am I telling wrong? Sorry, I'm talking unconsciously. When you are discussing about inductor, you cannot reverse the direction of the current before charging. Suppose when it is charging, its direction is going from left to right. During the discharging also, direction of the current will be remained same. But when it is, but the polarity will get reversed. During charging, if it is plus and this is minus, when it is discharging, this will become minus, this will become plus. This is the inductor. If you take the capacitor, in case of capacitor, during charging, if it is plus and minus, during discharging also, you will have the same polarity. But what about the direction? During charging, it is acting as a load. So current entering point plus, leaving point is minus. During discharging, it will be acting as a source. So current entering point should be minus, leaving point should be plus. So direction of the current will change in case of capacitor. So this will be during charging, and second will be during discharging. So direction of the current will get reversed in case of capacitor. Polarity of the voltage will get reversed in case of inductor. Do remember this basics. So here like that, if you observe, initially it might be plus, here it might be minus. Now it get reversed. This will become minus, this will become plus, because it will going to deliver the energy after 180 degree. So through which thyristor it will free will. The problem is, see, I told you now, this positive polarity, this positive energy will be higher than the negative energy offered by the thyristors, sorry, offered by the supply. Because of that, once again this positive voltage will be forcing the thyristor T1 and T2 will be continuing its conduction. Why thyristor T1 and T2 will be turned off after 180 degree? Because the polarity of the supply will get reversed, so immediately negative voltage will get reflected across the anode terminal of thyristor T1 and T2. Now that case will not happen just for some time, at least for some time. Sometime means, see, this negative supplies keep on injecting the negative energy. This negative energy will going by the positive energy stored across the inductor. After some point, what will happen is, so till that point you can observe the supply voltage will coming through the thyristor T1 and T2, and it will be appeared across the output. It will be continuing. I know it is negative voltage. That negative voltage will be started appearing across the output terminal because of the energy stored across the inductor will get free wheels through the thyristor T1 and T3, T1 and T2. So it will be allowing the negative voltage till some point, till some extent. After that, what will happen, sir? So till that point, what will happen is the energy across the inductor will get discharged, discharged, discharged. Then it will be reaching zero. This is the basic waveform. Then the same pattern will get repeated once again after pi by 3. Let us take it will be pi plus pi by 3. That is called pi plus alpha. After pi plus alpha, let us take extinction angle. Basically, this point is called extinction point. Till which point the thyristors are in conduction. That is called extinction point. I am assuming extinction and firing angle both are equal here. I am just assuming. So after that, what will happen? Same waveform, same pattern will get repeated one more time. So this is the conclusion. Okay sir. அப்ப இங்க என்ன நடந்திருக்கும்? Thyristor initially நம்ம இங்க 0 voltage போட்டோம் இல்லையா? So this is very first time நீங்க switch on பண்ணும்போது this is the pattern you can observe. Otherwise thyristor T1 T2 turn on ஆகிறதுக்கு முன்னாடி T3 T4 already turn onல இருந்திருப்பாங்க. You can observe this pattern there. Did you understand? That's all. So after that, this waveform will get continued. Again, positive voltage will come, again negative, again positive, again negative. This waveform will be continuously appearing in the output side. Similarly, here also you can observe that discharging will be happen here. Again, it will be charging. Again, it will be discharging. It will be continuously happening. Okay, sir. Now you might have understood, and I told here they haven't talked about the extinction angle. Question la extinction angle kudukala appadina, you can assume that extinction angle will be equal to 5 plus alpha. அதாவது அடுத்து நம்ம thyristor வந்து எப்போ ஃபயர் பண்றோமோ அதுக்கு ஈக்குவலா வந்துரும். If it is not given, by default you can take. Remember that. Okay sir. Now it is time to calculate the average value of the thyristor current. If you observe, thyristor will be in conduction from pi to pi plus alpha. Thyristor T1 and T2. This pair is in conduction. Similarly, for the same period from pi plus alpha to 2 pi plus alpha, T3 T4 will be in conduction. So you no need to consider all the thyristors. You can take any one pair. Only one thyristor also you can take. It doesn't matter. If you take only T1, what is the period from alpha to pi plus alpha? Current will be flowing. How will you calculate the average current now? See, I have spent so many minutes here. I know that. But try to understand how to do the operation, how to draw the waveform, and what is the extinction angle. Extinction angle means that is the ending point of the free will energy. Inductorல ஸ்டோர் ஆயிருக்க எனர்ஜி வந்து கம்ப்ளீட்டா டிஸ்சார்ஜ் ஆயிட்டு முடிகிற பாயிண்ட் தான் எக்ஸ்டிங்ஷன் ஆங்கிள். This you cannot observe this extinction angle when the load is purely resistive. Why? Because if you have only resistive load, then there is no person to force your thyristors to continue its energy, to turn on, to continue its conduction. Such kind of things will not happen when you have only resistor. If inductor is there, then some amount of energy will be stored there. That energy will free wheels through the thyristors. Okay, then you can observe this kind of patterns. Okay sir, fine. So it's time to calculate average value of the thyristor current. Let us calculate. Here I am saying that I naught average will be equal to average value of the thyristor current, because I have drawn the waveform of output only, not thyristor. But in case of fully bridge, full controlled, I understood that whatever the current that is going through the thyristor, same current will be going through the output also. So both are same, there is no difference. Then how will you calculate the average? Average value means fundamental formula is area divided by time period. You all know this is the fundamental formulas. This will be equal to area when the waveform is not what I can say standardly different waveforms. Standardly different means if I will have rectangular waveform, I know how to calculate area. If I have triangular, I know how to calculate area. If I have rectangular parabola, rectangular hyperbola, for something we have already have some standard equations, we can easily put it. But this waveform is quite little different. It is not like the same that we have observed earlier. Yes or no? Yes sir, it is not like others. So what should I do? In order to calculate this average value of the thyristor current, I have to go with the integral functions. So what you can do is, you can simply do like this. Sir, I may not be able to calculate the value of average value of the thyristor current directly. Yes, no issues. No issues. You can go with the same Vm sin omega t divided by resistor C. Average value of the thyristor can be written like this. average voltage divided by time period t. Can I write like this? And I have to, 1 minute guys, this is not t, this is r. According to Ohm's law, I naught average equal to V naught average divided by r. So what is the formula to calculate the V naught average now? Why I am not directly calculating I naught average? See, it is in charging nature. It is not similarly, it is not same as the sinusoidal waveform. So instead of focusing on this current, I am calculating V naught average. Then I am going to divide it by R, such that it will be easy to calculate the answer. Now, how will you calculate the V naught average? V naught average, as usual, the formula is area by time only. It is following standard sinusoidal waveform, so it is easy to calculate. So area will be in integral only. Under that integration period will be alpha to pi plus alpha. You can observe, I have already told you that we are drawing the waveform from alpha to pi plus alpha only. Here pi plus alpha equal to extinction angle beta. Don't forget. Basically, we will be calculating. The formula should be derived from alpha to beta only. But in your question, they haven't given any information about the extinction angle. So by default, if there will be no extinction angle data in your question, you can assume that extinction angle will be equal to next to firing angle pi plus alpha. This is very important point. Okay, sir. So alpha to pi plus alpha. And formula is what? As usual, you will be receiving Vm sin omega t only. Sinusoidal waveform only we are receiving for the output voltage, but only from alpha to pi plus alpha with respect to d omega t. That's all. Now, if you reduce this expression, you will be coming up with the answer. I hope hereafter you no need of my help. Sin omega t will give you minus cos omega t integration alpha to pi plus alpha. Then you can reduce this expression further. I'm keeping Vm by R into minus cos of pi plus alpha. See, already there is one minus. While going up with the lower limit, you will be coming up with one more minus. So minus into minus will be plus, and omega t will be replaced by alpha. What is the value of cos of 180 plus alpha? It will be equal to minus cos alpha. Already one more minus is there outside. So it will become plus. So I can write Vm by R. Cos alpha plus cos alpha will become 2 times of cos alpha. Finally, we got the answer. Now it is time to substitute all the values. So 2 times of maximum voltage divided by R into cosine of alpha is the formula to calculate the average value of the current through the thyristor or average output current. Yes or no? So let us substitute. 2 into what is the supply voltage? Given supply voltage. Let us go to the question. Supply voltage is 110. But do remember, I have told you in case of AC circuits, always they will be giving you RMS voltage. Whereas I need Vmax. So maximum voltage equal to root 2 times of RMS voltage. So it will be root 2 into 110. I have to substitute root 2 here. Then substitute 110. Upon the value of resistor, I think it is 10 ohm into cosine of pi by 3. It is equal to 60 degree. 180 by 3. It is equal to 60. I hope cos 60 will be 1 by 2 only simply. So you can replace this cos 60 by 1 by 2. So this 2 will get cancelled out and this 10 will get cancelled out. It will be root 2 into 11. I hope you all know the equivalent value of root 2. Root 2 will be 1.414 into 11. Now it is very easy to multiply these two. Yes, sir. So just to do the multiplication and put your answer. So this is how we are solving the question. Okay, so don't uh, try to directly write down the formulas when you don't remember. You may not get the answer. If you remember the formula, then there will be no issues. If you remember the idea, then you can easily put your answer to get the answer. Okay, fine, sir. Uh, I hope every one of you got the same as I did here. So let us go ahead with the next question. See, எப்பயுமே power electronics பொறுத்த வரைக்கும் what one thing you should keep in your mind is you have to be crystal clear how to draw the wave if you want to be placed in top ranks, because sometimes they will give some random circuit. They will replace the thyristor by diode. Single diode கொடுத்துட்டு 3 thyristor கொடுப்பாங்க. Sometimes they will give 3 diodes with the 3 thyristor, 3 diodes with the single thyristor. Sir, RL load only I naught average equal to V naught average by R load only. Rajesh, I am not getting you. Sir, R load only I naught average equal to V naught average by what you are trying to say? Resistive load இருந்தாதான் you are taking like this, I naught average equal to V naught average by R அப்படின்னு போடணும்னு சொல்றீங்களா? Am I right? You are telling this one only. Yes or no, Rajesh? See, let me tell you. Listen. Basically, this converter is converting the energy from AC to DC. Yes or no? You all know this. When the moment I'm telling that the output is DC, so here we are trying to receive DC pulse only. When you are injecting DC pulse to the inductor, you know what will happen? Basically, inductor will not accept instantaneous changes. But what it will do, you know, DC transient, we have been analyzed the response of RL circuit. Initially, what will happen is transient effect will be appearing. That's why I haven't written the charging current directly. Total time pi is missing. Okay, ma'am. In derivation, I missed something. No issues. That I will do. Listen here. When we are considering DC transient, this inductor will be taking some time to get charged. அதனால நான் சார்ஜிங் கரண்ட் ஆஃப் தி இண்டக்டர் டைரக்டா கன்சிடர் பண்ணல. இப்போ நம்ம கால்குலேட் பண்ணும்போது why I have taken V naught average is it is very easy to calculate. Otherwise, I have to write the transient current when RL circuit is connected with the transient, how inductor will get charged. I have to calculate the initial current, final current. Then from that we can derive the average current. So that things is little bit quite interesting and it will be lengthy too. In the examination point of view, it is better to avoid. Whenever RL circuit is given or RLE circuit will be given to you, try to go ahead with the V naught average, which will be easy to calculate. In case of RLE load, you can calculate I naught average. Battery will be there in the output side, so inductor will be short circuited. When we are having RLE load, if RLE load is given, battery is always connected constantly with the inductor, so it will be short circuited. Only you can observe current, so people won't consider the effect of inductor. So conclusion is, if you observe RL circuit, RLC circuits anywhere in the rectifier circuits, they won't consider the effect of the current flow through the inductor, because basically it will be carrying DC current in the output side, it will get short circuited. That transient effect will be there, but we are not considering because I'm going up with the voltage, I'm not going up with the current. Okay, so after that, at the end, if you see in steady state, inductor will be short circuited, then what is the point of considering that effect while calculating the current? It is not there. It is there, energy is there, current flow is there, but inductor will be behaving as a short circuited one. Distortion effect will be there. We are not supplying pure DC waveform here, I know that, but we people are assuming that effect is reached steady state, and we are not considering that effect. Okay, so whenever you are having RL load in the output side, don't consider the effect of transient for the inductor. Only keep your attention with the resistor. Just assume that inductor is in steady state. So simply write down the formula for the voltage. In case of RL load, then calculate the value of current. Similarly, if you are having RLE load, inductor will be, by default it will be short circuited. So you can write, in case of RLE load, you will be considering the effect of only R and E. Then you can write down the voltage expression, current expression. Then output will become simply, you are treating it as a RE load. In DC machines also you are doing the same. Do you remember? Effect of RE load. அதெல்லாம் நம்ம என்ன பண்ணுவோம் அப்படின்னா, பேசிக்கலி RE லோடு மட்டும் அவங்க கொஸ்டின்ல கொடுத்தாங்க அப்படின்னா, இதை நம்ம வந்து டிசி மிஷின் அப்படின்னு நம்ம ட்ரீட் பண்ணுவோம். ஐ ஹோப் யூ ஆல் ரிமெம்பர் தட். இதான் வந்து டிசி லோடுன்னு சொல்லுவாங்க. கொஸ்டின்ல வந்து டிசி லோடுன்னு கொடுத்தாங்க அப்படின்னா, யூ ஹாவ் டு ரீப்ளேஸ் இட் பை RE load only, because inductor effect is there in DC machine also, but energy will be stored across the inductor, no doubt about it. Current will be flowing through the inductor, but it will be behaving as a short circuited one, so we will not be considering the effect of inductance here. So RE load means its equivalent value is what? It is talking about DC machine only. There also inductor presence is there, but we are not considering it. Like that, when the moment they are giving RLE load also, definitely transient effect is there, but we are not considering. We are doing these calculations under steady state, which will be constant permanently. So that's why we are not neglecting that effect. I hope you all will understood all these things. Okay, so don't consider the effect of inductor while calculating these things. So just to discriminate it, While calculating RL load, calculate V naught average first, then directly calculate I naught average. Similarly, while calculating RLE load, if you want to know the value of V naught average or I naught average, first go ahead with the I naught average. It is easy to calculate. Simply you can do the evaluation, because derivation wise, if you calculate I naught RMS or V naught RMS, I naught average, V naught average in case of RLE load, if you go with the voltage calculation, derivation will become lengthy. If you go with the current calculation, derivation will be simple. That's why nothing is there, just a simple observation. So go ahead with the I naught average, simply calculate the current flow through the RLE circuit, but don't consider the effect of L. I told you the reason now clearly. Okay, I hope you all understood. Did I did any mistake here? They told I missed something. Okay, this time period T I missed. Alright. Yes, you can put it now. It is pi only, no? Duration. Just divide your answer by pi, you will be coming up with the answer, correct answer. That's all. Sir, why I am putting pi? Don't get confusion. See there, what is the duration of the waveform? Total is pi plus alpha. Total is pi plus alpha. I need only this duration. This duration. This portion is alpha. How will you do that? Pi plus alpha minus alpha will give you pi. So that is the duration of the waveform for the voltage and the current both. Okay. So you can keep directly that value. Pair of thyristor we find average value. Single thyristor divided by 2 போடணுமா sir? No, 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 not required. Listen, what you have to observe here is, இப்போ நீங்க கவனிச்சு பார்த்தீங்கன்னா good question, but think logically. So according to our common sense, if you observe ஒரு 180 degree நம்ம எடுத்துக்கிட்டோம் அப்படின்னா thyristor T1 and T2 conductionல இருக்கா. See, from alpha to pi plus alpha, thyristor T1 and T2 are in conduction. Yes or no? Again, if you take from pi plus alpha to 2 pi plus alpha, thyristor T3 and T4 are in conduction. Now, if you take the whole 360 degree from alpha to 2 pi plus alpha, if you take thyristor T1, T2, T3, T4 all are in conduction. I am just asking you a question. Observe the waveform and tell me what is the conduction period of the thyristor T1. I am just asking you. What will you tell? Conduction period, for how many angle, for how much angle thyristor T1 will be in conduction out of 360 degree. What is the conduction angle of thyristor T4? Similarly, if I am asking, what will you tell? If I will ask you like that, you should observe thyristor T1 will be in conduction from alpha to pi plus alpha, so that duration will be 180 degree only. If you observe thyristor T2, that is also in 180 degree. T3, from pi plus alpha to 2 pi plus alpha, T3 will be in conduction, that is also 180 degree. T4 also in 180 degree. So it doesn't matter whether you are taking a pair of the thyristor or a single thyristor, here the conduction period will be same. That's what I told you. Basically, they have asked us to calculate the average value of the current flow through the thyristor. So I am observing only thyristor T1. If I will observe thyristor T1 and T2 also, why I am putting T1, T2 basically here? Because thyristor T1 and T2 both are carrying the identical waveforms. So instead of drawing them separately, I can combine them. The current flow through the thyristor T1 is flowing through the thyristor T2 also. So instead of showing them separately, I can show that both are identical to each other, because same waveform will be going from here and here. So I'm just combining them. Okay, so don't divide by 2 or multiply 2. These kind of things are wrong. Just apply your common sense. So both are conducting at the same time and the same waveform will be flowing through the both thyristor. That's why I'm putting T1 and T2 are in conduction at the same time period. Okay, so this kind of doubts should not be appear hereafter. Only focus on only one thyristor. Don't think about whether we are taking T1, T2, T3, T4 at all. T1, what is the conduction period? 180 degree. Just to calculate it. That's all. Okay. Fine, sir. I hope you understood this. Let us go ahead with the next question. Let me drop the next question. Okay. See, the question is the effect of 1 minute, guys. Sorry, forgive me. In single phase, not effect, let me read. In single phase full converter, in single phase full converter, in single phase full converter, delivering, what it is doing is, just observe the question, delivering an output. Each and every keyword I am dropping a question by question, such that everything will be cleared out. Delivering ripple free load current. Output ripple free load current. What is the meaning of ripple free load current? So ripple free load current. Load current of 10 ampere. Okay, sir. Average value of the thyristor current in ampere will be dash. Once again, the question is, what is the average value of the thyristor current? That's all. Average value of the thyristor current. Guys, remember, here I just wanted to confirm one thing. See, output is ripple free. What is the meaning of this one? Basically, what our rectifier will do is, we are giving sinusoidal waveform. If you observe only rectifier, we are observing only rectifier. We are not keeping any filter circuits here. So this rectifier will be giving you pulsating waveform only. The nature of the output will be in pulsating. Nature of the output waveform will be pulsating. Then what people will do? People will be keeping filter circuits here. What filters? Basically, we will be using capacitor. We know, suppose I'm just asking you, let us assume there is one load here. Okay, I will be clearing this doubt here. Listen, assume there is one load, and across the load I am connecting a simple capacitor. Now tell me what will happen. See there, initially when the moment, very first time when you are charging this circuit, capacitor will be charging. But remember, output is pulsating DC only. So basically it is DC waveform. When a capacitor is connected with a DC supply for a very long time, what will happen? The natural behavior of the capacitor will be, it will be simply acting as a open circuited with a constant voltage. Capacitor will charge up to the maximum peak voltage of the pulse. First it will be charging up to the maximum value of the supply pulse. So once it is charged up to the maximum value, then it will discharge if there will be any loads available in the circuit. அதனால வந்து டிஸ்சார்ஜ் பண்ண முடிஞ்சது, அந்த டிஸ்சார்ஜ் பண்ண நீங்க அலோவ் பண்ணீங்க அப்படின்னா அது டிஸ்சார்ஜ் பண்ணும். அப்படி இல்லைன்னா அது அப்படியே கான்ஸ்டன்டா நின்றும். ஆர் யூ கெட்டிங் மீ? கெப்பாசிட்டர் ஃபுல்லா சார்ஜ் ஆயிடுச்சு. சார்ஜ் ஆனதுக்கு அப்புறம் அதை எடுத்துட்டு போயிட்டு, இப்போ மொபைல வந்து நம்ம ஃபுல்லா சார்ஜ் பண்ணிட்டு நம்ம யூஸ் பண்ண ஆரம்பிச்சாதான் என்ன ஆகும்? சார்ஜ் வில் பி ஸ்லோலி டிக்ரீசிங் டவுன். அதர்வைஸ் த டிக்ரீசிங் ரேட் வில் பி வெரி லெஸ். தோ இட் வில் டிக்ரீஸ். அதுக்குள்ள என்ன ஆகும் அப்படின்னா, சம் அட்மாஸ்பியர் அஃபெக்ட், இன்டர்னல் ஃபேக்டர்ஸ் வந்து என்ன பண்ணும் அப்படின்னா கொஞ்சம் கொஞ்சமா சார்ஜ் குறைக்கும். பட் தட் எஃபெக்ட் இஸ் நாட் தட் மச் ஹை. I can say it is very less. So what is the conclusion here? Simply I can say this capacitor will be constant as long as you are not allowing the capacitor to get discharged. So the conclusion is, it will be acting as a constant source with a positive and a negative polarity, because in this direction only we have charged the capacitor. See there, if the capacitor is parallelly connected with the load, it doesn't matter whether we are sending pulsating waveform from the input or not. From here, this side, output will be what? It will become constant. How it happened? Because the load is connected in parallel with the capacitor. This is how filter circuit will work. இது என்ன பண்ணோம்னா, capacitor வந்து இந்த pulsating charge எடுத்துக்கிட்டு full charge ஆயிடும். Once it is fully charged, then it will try to maintain the constant voltage across the load, like our Zener diode. That will also do the same thing, but that operation will be different. That will also be used for voltage regulator. Voltage regulator means we are trying to regulate the output voltage constantly. That is filtering action. Like that, இந்த மாதிரி பண்ணாங்க அப்படின்னா என்ன நடக்கும் அப்படின்னா, output will become ripple free. The nature of the output voltage will become ripple free. Similarly, if you use the inductor என்ன பண்ணும்? Inductor will be charging in terms of current. I was talking about voltage now. Capacitor will be charging up to maximum voltage. Inductor will be connected in series with the load. Now tell me what will happen. If I will pass some pulsating current through the inductor will be charging up to the maximum peak current of the pulse. Then what will happen? Then if you stop sending this pulsating nature of the current, then inductor will discharge that energy. Suppose if I am continuously sending this pulsating current, then inductor will be constantly, it will be charged up to certain maximum value, then that energy will be constantly maintained. See there, inductor current will be constantly maintained. Though you are sending the pulsating current, though your nature of the current is pulsating, the current will become constant once you keep the inductor in series, such that current will become ripple free. அதனால தான் நம்ம என்ன சொல்லுவாங்கன்னா, இப்போ எந்த ஒரு டிசி சர்க்கியூட்ஸ்ல பாத்தீங்கன்னாலும் கொஸ்டின்ல வந்து சொல்லியிருப்பாங்க, we are trying to keep the high value of inductance in order to maintain the ripple free current in the output side அப்படின்னு சொல்லுவாங்க. So actual reason is inductor will be charging. Transient effect will be there in inductor current only for a certain very few nanosecond. That too also at the starting. After that, the transient effect will be dies out. Inductor current will become constant. Then it doesn't matter whether you are sending pulsating current or not. Output current will become constant because inductor is connected in series with the load. So when the constant current is started flowing through the inductor, same current will be entering or flowing through the load also, such that output current will become ripple free. So whenever they are saying, see, a single phase full converter is delivering output current ripple free, in the sense they have used, what is the actual meaning of that? Now you should understand. It's time to explore your knowledge. Output la current வந்து அப்ப ripple free ஆ வந்திருக்கு அப்படின்னா, they are talking about current only, load current. Current அப்ப ripple free ஆ வந்திருக்கு அப்படின்னா, with the load they have connected one large value of inductance. That inductance is trying to maintain the value of current as constant. Because of that, we are getting ripple free current in the output side. Did you understand? So this is the basic operation of the circuit. நீங்க இண்டக்டரை டிஸ்சார்ஜ் பண்ண அலோவ் பண்ணல, அது அப்படியே கான்ஸ்டன்டா விட்டுட்டீங்கன்னா போதும். இண்டக்டர் வந்து என்ன பண்ணணும் அப்படின்னா அதை கான்ஸ்டன்டா மெயின்டைன் பண்ணிடும். So it will become automatically ripple free circuit. Now you might understood how we are maintaining the output voltage as ripple free, output current as ripple free. For voltage, you must connect one capacitor across the load. You know the reason. Voltage output la constant ah varana, adukku parallel ah irukka someone வந்து, ஏன்னா voltage வந்து parallel circuit la தான் same ah இருக்கும், current வந்து series circuit la தான் same ah இருக்கும். That's why we are connecting inductor in series with the load, capacitor in parallel with the load. இந்த பேசிக் காம்பினேஷனை வச்சு தான் நம்ம என்ன பண்ணிருப்போம் அப்படின்னா சாப்பர் சர்க்யூட்ஸ் வந்து டிசைன் பண்ணிருப்பாங்க. நீங்க சாப்பர் சர்க்யூட்ஸ் எல்லாம் படிச்சீங்க அப்படின்னா அவுட்புட்ல எல்லா இடத்துலயுமே கெபாசிட்டி இண்டக்டர் போட்டிருப்பாங்க. தி ரீசன் இஸ் வாட், we are trying to maintain the ripple free because we are trying to change the DC voltage. DC வோல்டேஜோட லெவலை வந்து நம்ம சேஞ்ச் பண்ணும்போது என்ன ஆகும் அப்படின்னா, ஒரு லெவல்ல இருந்து இன்னொரு லெவலுக்கு நீங்க இன்க்ரீஸ் பண்ணும்போது கண்டினியூஸ்லி டிரான்சியன்ட் எஃபெக்ட் இஸ் தேர். I don't want these things. I just wanted to maintain the constant values. I should level down or level up the voltage, but during that during the leveling of the voltages, I just wanted to maintain the constant voltage and the constant voltage in the constant current in the output circuit. For that, we are using these filtering elements. Now you might understood how these two people are acting as a filters. Now come back to the circuit. Anyway, my conclusion is over about the properties of inductor and capacitors. So output ripple free means one large inductance is connected in series with the load. Because of that, current is maintained as constant one, 10 ampere. Okay, it is single phase full converter. Now it's time to explore the value of average value of the thyristor current. Now you can drop your answer. Take your time, no issues, but I need answer. That's all. இப்போ நம்ம லாஸ்ட் கொஸ்டினை சால்வ் பண்ண பார்த்தீங்களா, உங்களுக்கு அப்பயும் அந்த இடத்துல இந்த டவுட் வரணும், சார் அங்கேயும் வந்து நம்ம வந்து இதே மாதிரி போட்டுக்கலாம் இல்லையா கான்ஸ்டன்ட் அப்படின்னு சொல்லிட்டு அப்படின்ட்டு. ஆனால் அங்கே என்ன ஆயிடுச்சு அப்படின்னா அவங்க இந்த மாதிரி சொல்லலை. இண்டக்டர் வந்து லார்ஜ் வேல்யூ கொஸ்டின்ல கிளியராக டிஃபால்ட்டாக மென்ஷன் பண்ணுவாங்க. எல்லா இடத்துலையும் ஆர்எல்லோட வந்துட்டாலே அப்போ அவுட்புட் கரண்ட் கான்ஸ்டன்ட் ஆகிடுமா அப்படின்னு கேட்டால் நோ, இட் இஸ் நாட் லைக் தட். ஏன்னா இப்போ நீங்கள் லாஸ்ட் கொஸ்டின் அப்சர்வ் பண்ணுங்களேன், நமக்கு என்ன ஆச்சுன்னா வேவ் ஃபார்ம் வந்து டிஸ்சார்ஜும் ஆச்சு. ஆஃப்டர் பைக்கு அப்புறம் பார்த்தீங்க அப்படின்னா ஒரு பர்டிகுலர் டைம் வரைக்கும் பைல இருந்து பை பிளஸ் ஆல்ஃபா அந்த டியூரேஷன்ல பார்த்தீங்கன்னா தைரிஸ்ல T3 T4 ஆன் ஆகல. ஏன் ஆன் ஆகல அப்படின்னா ஃபயரிங் ஆங்கிள் கொடுக்கல. நீங்க ஆல்ஃபா வந்து கொடுக்கல அப்படின்னா தைரிஸ்ல T3 T4 ஆன் ஆகாது. அப்புறம் T1 T2 என்ன ஆகும் அப்படின்னு பார்த்தீங்கன்னா T1 T2 வந்து நெகட்டிவ் வோல்டேஜ் வந்து சப்ளைல இருந்தோம், பாசிட்டிவ் வோல்டேஜ் வந்து இண்டக்டர்ல இருந்து ரிசீவ் பண்ணிட்டு இருக்கு. அப்போ பாசிட்டிவ் எனர்ஜி சப்ளைடு பை இண்டக்டர் வந்து சப்ளையோட நெகட்டிவ் எனர்ஜியோட அதிகமா இருக்கிறதுல T1 T2 என்ன ஆயிடும் அப்படின்னா பை பிளஸ் ஆல்ஃபா வரைக்கும் அதோட கண்டக்ஷன் வந்து கண்டினியூ பண்ண ஆரம்பிச்சிடும். அப்ப அந்த டைம்ல என்ன ஆகும் அப்படின்னு பாத்தீங்கன்னா எனர்ஜி இண்டக்டர்ல ஸ்டோர் இருக்க எனர்ஜி வந்து ரெசிஸ்டர் வழியா ஃப்ரீ வீல் ஆக ஆரம்பிச்சிடும். ஆட்டோமேட்டிக்லி எனர்ஜி வில் பி டிசிபேட்டட். இந்த மாதிரி நடக்கிறதால தான் என்ன ஆகுது அப்படின்னா சார்ஜ் ஆன இண்டக்டர் வந்து திரும்பவும் டிஸ்சார்ஜ் ஆச்சு. இதே வந்து நீங்க வந்து கரெக்டா வந்து அட் பை கரெக்டா 180 டிகிரி ரீச் பண்ணும்போது இண்டக்டர் வந்து மேக்ஸிமம் எனர்ஜி ரீச் பண்ணிடுச்சா, இமிடியேட்டா வந்து நீங்க என்ன பண்ணிருக்கணும் அப்படின்னா தைரிஸ்டர் T3 T4 வந்து நம்ம ஆன் பண்ணோம் அப்படின்னா லைக் இண்டக்டரோட எனர்ஜி வந்து நம்ம டிஸ்சார்ஜ் பண்ண விடாம நம்ம வந்து ட்ரை பண்ணோம் அப்படின்னா என்ன ஆகும், இண்டக்டர் வில் ட்ரைஸ் டு மெயின்டைன் திஸ் எனர்ஜி. அது என்ன பண்ணா கரண்ட் வந்து கான்ஸ்டன்டா அதை மெயின்டைன் பண்ண ட்ரை பண்ணும். திஸ் திங்ஸ் வில் பி பாசிபிள், but it should be possible only when we are trying to keep large value of inductance. அது இன்னொரு விஷயம் என்னன்னு பாத்தீங்கன்னா, அப்ப என்ன பண்ணுவாங்கன்னா இண்டக்டரோட எனர்ஜி இண்டக்டரோட வேல்யூ வந்து நீங்க லார்ஜ் வேல்யூ அப்படின்னு கொஸ்டின்ல கீ கொடுப்பாங்க. நார்மலா RL லோட்ல வெறும் RL லோட்னு கொடுத்தா அப்படி வராது. லார்ஜ் வேல்யூ ஆஃப் இண்டக்டன்ஸ்னா என்ன ஆகும்னு பாத்தீங்கன்னா, சப்போஸ் ஆல்பால நீங்க தைரிஸ்டர் ஆன் பண்றீங்கன்னா இட் வில் பி சார்ஜிங், இண்டக்டர் வில் பி சார்ஜிங் அப் டு 180 டிகிரி. அதுக்கப்புறம் என்ன ஆகும் அப்படின்னு பாத்தீங்கன்னா, இண்டக்டரோட வேல்யூ வந்து நீங்க அதிகமா வச்சிருந்தீங்க அப்படின்னா இது what is the meaning of high value of inductance? It will take more time to discharge, slower discharge ஆகும், because அதோட ability வந்து ரொம்ப அதிகமா இருக்கும். So you have designed a super inductor, so it is taking more time to discharge. அது டிஸ்சார்ஜ் ஆகிறதுக்கு முன்னாடியே நீங்க திரும்ப அடுத்த ஃபயரிங் ஆங்கிள் வந்து கொண்டு வந்துட்டீங்க அப்படின்னா என்ன ஆகும், see there again it will be started charging. இப்போ நீங்க இண்டக்டரோட வேல்யூ இன்னும் அதிகமாக்குறீங்க, நோ சார் நான் இன்னும் அதிகமாக்கணும்னு நினைக்கிறேன், எனக்கு இந்த மாதிரி பல்ஸே வரக்கூடாது, நான் கண்டினியூஸா வரணும், I would like to receive the continuous waveform, like ripple free waveform வரணும் அப்படின்னா இண்டக்டன்ஸோட வேல்யூ இன்னும் அதிகமாக்குவாங்க. அப்ப என்ன ஆகும் அப்படின்னா அந்த டிஸ்சார்ஜ் வந்து ரொம்ப கம்மியா தான் ஆகும். இட் வில் பி கோயிங் லைக் திஸ், ஆல்மோஸ்ட் வந்து என்னடா சீதர் வேவ்ஃபார்ம் வந்து இந்த மாதிரி வந்துடும். பியூரா கொண்டு வர முடியாது, பட் ஆல்மோஸ்ட் we are getting close to constant value. This could be possible when we are designing super inductor. என்ன அப்படின்னா இப்போ டிகே ஆகிறதுக்கான டைம் கான்ஸ்டன்ட் எடுத்துப்போம் இல்லையா, we will be talking about tau. Tau means what? Time taken by the inductor to charge, or inductor to charge up to 60%, or time taken by the inductor to discharge up to 30%. Basically we'll be talking about 63-37. I know exact value is 37%, it is 63%. So this is randomly I'm telling. So அப்போ என்ன ஆகும் அப்படின்னா அந்த டைம் கான்ஸ்டன்ட் வந்து ரொம்ப கம்மியாயிடும். இண்டக்டர் வந்து என்ன ஆகும் அப்படின்னா சார்ஜ் ஆகிறதுக்கு வந்து ஸ்லோலி இட் வில் பி சார்ஜிங் அப் டு மேக்ஸிமம் வேல்யூ, தென் இட் வில் டேக் மோர் டைம் டு டிஸ்சார்ஜ். 30% டிக்ரீஸ் ஆகிறதுக்கு ரொம்ப டைம் வந்து அதிகமாக எடுத்துக்கும். தட் இஸ் வாட் வி வாண்ட். அந்த மாதிரி டிசைன் பண்ணிட்டாங்க அப்படின்னா ஆட்டோமேட்டிக்லி யுவர் சர்க்யூட் வில் பிகம் ரிப்பிள் ஃப்ரீ. தட்ஸ் ஹவு பீப்புள் ஆர் டூயிங் திஸ். அப்போ இந்த கண்டிஷன் வரணும் அப்படின்னா கொஸ்டின்ல என்ன கொடுக்கணும், ஒன்று டைரக்டா இந்த மாதிரி ரிப்பிள் ஃப்ரீ கரண்ட்னே கொடுத்துருவாங்க. அதர்வைஸ் தி செகண்ட் திங் வாட் தே வில் டூ இஸ் the value of the inductance is very large அப்படின்னு கொடுத்துட்டாங்கனாலே by default you have to assume that the output current will become ripple free. Ripple free means you are receiving constant current. Outputல we are receiving pure DC அப்படிங்கறத நீங்களும் assume பண்ணிக்கலாம். That's all. What you people are doing, I just asked you all to calculate the average value of the thyristor current. I have explained everything from my end. It's over. It's time to explore the value of average current. Do it. Okay. நான் என்ன சொன்னேன், if you don't know then draw the waveform. Sir, previous circuit continuous conduction, circuit turn off time. ராஜேஷ் அந்த இடத்துல தைரிஸ்டர் T1 T2 தான் வந்து தைரிஸ்டர் T1 T2 மட்டும் எடுத்துக்கிட்டோம்னா டேக் எனி ஒன் சர்க்யூட் டர்ன் ஆஃப் டைம் அப்படிங்கிறது இண்டிவிஜுவலா நம்ம பார்க்கணும். எல்லா தைரிஸ்டருக்கும் ஒரே வேல்யூ தான் வரும். Now do it by yourself. தைரிஸ்டர் T1 மட்டும் எடுத்துக்கிட்டு அது எவ்வளவு நேரம் கண்டக்ஷன்ல இருக்குன்னு பார்த்துட்டு ரிமைனிங் இருக்க டைம்ல எந்த இடத்துல வந்து அது நெகட்டிவ் வோல்டேஜ் பிளாக் பண்ணுதுன்னு வரையும். சிங்கிள் சைனசாய்டல் வேவ்ஃபார்ம் எடுத்துக்கிட்டு தைரிஸ்டர் T1 மட்டும் ஃபோக்கஸ் பண்ணுங்க. ஃபோக்கஸ் பண்ணி அது எந்த இடத்துல டர்ன் ஆன் ஆகுது, ரிமைனிங் எந்தெந்த இடத்துல வந்து நெகட்டிவ் வோல்டேஜ் பிளாக் பண்ணுதுன்னு பார்க்கணும். பிகாஸ் பேசிக்கலி we are calculating circuit turn off time only for the negative value of current, because that is called what, எந்த இடத்துல ஓகே எந்த இடத்துல நெகட்டிவ் வோல்டேஜ் வந்து அது பிளாக் பண்ணிருக்கு அப்படிங்கறத நம்ம பார்க்கணும் இல்லையா. ஸோ யூ மஸ்ட் ஃபர்ஸ்ட் draw the waveform, take one pure sinusoidal waveform. தைரிஸ்டர் T1 மட்டும் ஃபோக்கஸ் பண்ணி அது எந்தெந்த இடத்துல வந்து வோல்டேஜ் வந்து பிளாக் பண்ணிருக்குன்னு பார்த்து waveform வரைஞ்சிட்டு then estimate the value of circuit turn off time. சர்க்யூட் டர்ன் ஆஃப் டைமை வந்து நீங்க கால்குலேட் பண்ணும்போது டோன்ட் கன்சிடர் தி பாசிட்டிவ் வோல்டேஜ், பிகாஸ் பாசிட்டிவ் வோல்டேஜ் வந்து நம்ம எப்போ வேணாலும் ஆன் பண்ணிக்கலாம், எப்போ வேணாலும் உள்ள கொண்டு வந்துக்கலாம். தட் இஸ் டிபெண்ட்ஸ் ஆன் தி வேல்யூ ஆஃப் ஃபயரிங் ஆங்கிள். ஆனால் நெகட்டிவ் வேவ்ஃபார்ம் அப்படி கிடையாது. நெகட்டிவ் வந்து ஆட்டோமேட்டிக்காக வந்து என்ன ஆகிடும், தைரிஸ்டர் வில் பி டர்ன் ஆஃப். Do it by yourself. Rajesh, I need an answer from your end now. Other people, please drop the thyristor average current. Draw the waveform first. Good. Sadhana Gunasegaran got 5 ampere. ரிப்பிள் ஃப்ரீன்னு கொடுத்துருக்காங்கல்ல கிளியரா. இது வந்து ஒரு சிம்பிள் வேவ்ஃபார்ம். நான் வரையட்டுமா? இங்க பாருங்க, கொஸ்டின்ல அவங்க கிளியரா சொல்லிட்டாங்க அவுட்புட் வந்து ரிப்பிள் ஃப்ரீ சார்னு சொல்லிட்டாங்க. Input on the sinusoidal தான். I agree. Very good, very good. Many of you got the answer. Input on the sinusoidal waveform. Voltage வந்து நம்ம inject பண்றோம். Okay sir. Let me take only one waveform, that is enough. இப்போ பாத்தீங்கன்னா when I am trying to draw the output current, this is input voltage or input current, whatever you want to take, you can take. Okay, I am keeping voltage only, input voltage. With respect to this, if I will draw the output current, they told that output current is ripple free, in the sense I am drawing only up to 360 degree. Okay, such that same current will be continuous after 360 also. You can observe it will be continued, but I just wanted to focus on average value of the thyristor current, right? So now I am just asking you, it is 180 degree. Okay sir, there will be no doubt, undoubtedly this is the answer. Okay, sir. Now they clearly told that the circuit is ripple free now. Yes, sir, it is ripple free, and they haven't given any type of where edume kodukala, sir. The only term what they have given is average values. Sorry, output current is given. In the output current, now I am asking, firing angle is not given. Eppa turn on agum, eppa turn off agum, edume namakku theriyadu. But what we know is, out of 360 degree, in the total 360 degree, 180 degree will be contributed by one pair of thyristor. Are you guys are accepting that? ஏன்னா இங்க டிஸ்கண்டினியூஸ் கண்டக்ஷனே வரல. அப்படின்னா மீனிங் என்ன? ஒரு 180 டிகிரில தைரிஸ்டர் T1 T2 ஆன் ஆயிருக்கும், இன்னொரு 180 டிகிரில தைரிஸ்டர் T3 T4 ஆன் ஆயிருக்கும். இப்பதான் நம்ம வேவ் ஃபார்ம்லாம் பார்த்தோம். So definitely for the 180 degree, two thyristor will be in conduction. Another 180 degree, one more two pair thyristor will be in conduction. அப்ப நீங்க அப்சர்வ் பண்ணீங்க அப்படின்னா, suppose if I am considering only thyristor T1 and T2, T1 T2 positive cycle தான் ஆன் ஆகும். So it will be in conduction up to 180 degree. Output waveform and current flow through the thyristor both will be same. Here also same 10 ampere will be flowing, but only up to 180 degree. After that, what will happen? Thyristor T3 T4 will turn on. So current flow through the thyristor T1 and T2 will be turn off. Yes or no? It will be turn off. So here it will become 0 ampere. Now you can compare. See, you no need to take pair of the thyristor also. I told you the difference. Thyristor T1 and T2 are both will turn on at the same time, and they both carrying the same current. That's why we are treating them at a single time. Okay, so now tell me, out of 360 degree, now how will you calculate the average value of this current? Just to compare these two. You know the value of average thyristor average value. Let me estimate. The average value of the thyristor equal to average means area by time. Simply area by time period. Basically what you have to do is, here what is the area? Area means if you consider what is the total time period, we must consider total 360 degree. Thyristor will be in conduction only for 180. Out of 360 degree we have to consider. Total time period is 360 degree. But out of that 360 degree, our thyristor will be in conduction only for a particular duration. Particular duration அப்படினா only 10 to this one. So you have to consider that. So time period is up to only 180 we are considering. So it should become rectangular one. Area வந்து இது rectangular தானே. Rectangularக்கு area எப்படி calculate பண்ணுவீங்க? Height வந்து எவ்வளோ 10, length எவ்வளோ 180 degree. 180 degree divided by 360 degree. Degree will get cancelled. 180 by 360 will be 1 by 2. 10 by 2 will give you 5 ampere. See how simply I have estimated this. இதே இப்போ நான் வந்து output current எவ்வளோன்னு கேட்குறேன். அதே 360 டிகிரியில் average value of output current எப்படி சார் சொல்லுவீங்க? Average current as usual area by time period. Area எவ்வளோ? I am considering up to 360. In the current 360 வரைக்கும் exist ஆயிருக்கு. There is no zero. So I can say area will be 10 ampere and it will be available up to 360 degree divided by overall period also 360 degree. So it get cancelled here. So it will be equal to 10 ampere. Yes or no? So let us generalize the things. Okay, sir. Suppose if this current is not given, simply they given I. If it is given as simply I, then if you compare this one with the average current, ரெண்டுத்தையும் compare பண்ணுங்க. Here we are getting 10 ampere, here we are getting 5 ampere. It means if I will divide this by 2, then you will be getting 5 ampere. So from this I can say the average value of the thyristor current will be equal to average value of the output current divided by 2 in case of single phase full bridge rectifier with the continuous conduction. Continuous conduction means ripple free load. So that is the relation between thyristor current and output current for this type of load. Just note it down. உங்களுக்கு ஞாபகம் இருந்தா நீங்க அப்படியே போட்டுக்கலாம் 1 செகண்ட்ல ஆன்சரை. இல்லாட்டியும் பிரச்சனை இல்லை. இது ஒன்றும் அவ்வளோ பெரிய விஷயம் கிடையாது. It won't take much time. In 10 to 15 seconds you can draw the waveform and you can put your answer. Okay, sir. Suppose the question is calculate the RMS value of the thyristor current. Anyone? Can you help me? I just wanted to know the RMS value of the thyristor current. இதே தான் கொடுத்திருக்காங்க. Take the same data, but I just wanted to know the RMS value of the current. Anyone? Drop your answer in the comment section. In this question, they have asked only average. Suppose RMS current கேட்டிருந்தாங்கன்னா என்ன பண்ணுவீங்க? Same data. Outputல வந்து 10 ampere current flow ஆயிட்டு இருக்கு, ripple free continuous conductionல இருக்கு. Now எனக்கு வந்து RMS value of thyristor current வேணும் அப்படின்னா என்ன பண்ணுவீங்க? You know how to calculate the RMS. What is the formula? General formula. Don't memorize anything. எல்லாத்தையும் மறந்துடாதீங்க. Circuit theoryல we have been calculated RMS values of many waveforms and we know how to calculate the RMS value of any general waveform. Write down the general formula first. Then only you will get the answer. 7.07 ampere. Geeta. Very good. Any other? Good. Subumari. 7.017 ampere. Good. Any other? Chalo. See, suppose if RMS value is given, RMS value, if you are asked to calculate the RMS value, you know that is called root mean square. This is the basic formula. How will you write down? If the question is, if they asked any RMS value, root mean means average value. I must square the average value, then I have to take what? Root for that, mean square. Let me write down. First, we know average value means we will be calculating area by time. Undoubtedly, this is the formula. But then told that mean, root mean square. I have to take the square first, mean square. Yes, then we should first then calculate the value of area, square it, substitute the value of time period here. Then we have to put all these parameters under root. If you do that, automatically you will be coming up with the correct answer. So general formula, let me write. If you put integral in terms of mean square with respect to time period dt, and then you will be keeping whole time period here under root. That's all. You'll be coming up with the correct answer. Sorry, here I kept t also inside, right? Forgive me. Area square by time, then root mean square. You have to take square for that. It is over. Same. Both are same. Here I put integral when the value of, when the waveform is not known to as some random waveform is given. In that case, you can go up with the integral. If waveform is known waveform, then you can directly substitute the value 10 ampere into it is conducting up to 180 degree. Yes or no? Then you can calculate the area value, then divided by fundamental time period. Then you can take square root. You will be coming up with the correct answer. That's all. Fine, sir. I hope you all understood how to do these things. So here, let me bring one more question. Try to spend some time, but don't copy anyone. It's my suggestion. If you know, you can do. If you don't know, then just wait. Try to explore the formula to bring the answer. The question is, the effect of source inductance is given. The effect of source inductance in single phase, fully controlled in single phase. Just to note down the question, in single phase fully controlled bridge results in an equivalent resistance, in series with the internal voltage rectifier, in series with the internal voltage rectifier, What is the equivalent resistance? The question is, what is the equivalent resistance where Ls equal to 2 millihenry and frequency f equal to 50 hertz as is shown. It's a numerical type of question. Try to drop your answer in the comment section. Okay. And one more thing, see, in the RMS value calculation வந்து கொஞ்சம் டைம் ஸ்பெண்ட் பண்ணி கற்றுக்கோங்க. எப்படி வந்து நம்ம RMS value வந்து calculate பண்ணோம். See, it is very easy. இப்போ RMS value வந்து கேட்குறாங்க அப்படின்னா basically nature of the waveform. நம்ம தைரிஸ்டுக்கு தானே கேட்டோம். I know only waveform sir. Waveform is என்ன கொடுத்துருக்காங்க அப்படின்னா it is conducting up to 0 இருந்து 180 degree வரைக்கும் வருது. But we are estimating நமக்கு என்னன்னா 360 degree வரைக்கும் தான் நம்மளோட total time period. The fundamental time period is 360 or you can convert it into radian. Basically நம்ம values calculate பண்ணும்போது டிகிரில இருக்கிறத விட it will be in radian. Sometimes cancel ஆகும், sometimes cancel ஆகாது. So it's better to keep it in radiant. So அப்போ நீங்க radiantல வச்சுக்கிட்டீங்க அப்படின்னா it will be easy to calculate. இப்போ நம்ம இங்கே என்ன பார்த்தோம்? So this is 180 degree. I can keep it pi. இப்போ substitute பண்ணினா என்ன வரும்? Direct formula. Otherwise you can solve here also. Magnitude is 10. First என்ன பண்ணுவீங்க? RMS value வேணும் அப்படின்னா I know directly area is given sir. ஏரியாவுக்கு பதிலாக தான் நம்ம integral போடுவோம். I should keep all them under root. But area நீங்க என்ன பண்ணிக்கணும்? Square பண்ணிக்கணும். That is very important because root means square value. Fundamental formula. இது நம்ம வேற எப்படி எழுதுவோம்? I have written already 1 by t integral of time period. In the integral you have to keep the time period. Then whatever the function that you are going to keep, that magnitude you can keep and square it with respect to dt or d omega t whatever. After that once again you can put them all under root. This is the general formula. இங்க வந்து இந்த area into magnitude with respect to this is the simple formula for area. I told you this formula we will be using for some random equation. Sorry, for some random waveform. When the waveform is not clearly known, then you can use this. If you are not knowing the answer. Sir, எனக்கு waveform நார்மலா கொடுத்திருக்க waveform தான் அதுக்குமே எனக்கு ஃபார்முலா மறந்து போச்சு எனக்கு ஞாபகம் இல்லனாலும் you can use this formula, you will get the answer. எப்படி சால்வ் பண்ணுவீங்க? See, first of all, area square. I know for the rectangular, area means it is length into height. Height is 10, length is pi. So I am squaring it. Divided by total time period is how much? Total time period is already clearly given. That is 2 pi. We are considering up to 360 degree. You must keep all these people under root. If I will do that, 10 square will give you 100. Then here it will become pi square upon 2 times of pi. Don't forget this all people lies under root only. So 1 pi will be cancelling here. Yes or no? Yes sir. It will be automatically get cancelled out. Because here what I did here, I did some mistake. If you take 10 outside, 100 outside will become 10. If you take 2 outside, it will become 10 by root 2. I made some mistake. Time period is correct. It should be under 2 root pi. One second guys. It will be 1 by 2 pi. 10 square. Sorry. Only magnitude we have to square here. Forgive me. Area it is length into height, right? Magnitude மட்டும்தான square பண்ணணும் here. I have squared. See there. This is unconscious things. Magnitude square பண்ணிட்டு and then multiply it by correspondent width. Width is pi. Okay. See here. It will be pi only. 10 square into pi. So 100 into pi into 2 pi. Pi will get cancelled. It will become 10 by root 2. Here don't square area. I made a mistake. It is wrong. Area நம்ம எப்படி எழுதுவோம்? Height into width. Height should be square. This is magnitude, right? While calculating area, here also in the integral if you observe, I have squared only magnitude and then it will be multiplied by its corresponding time period. So here also you can do the same thing such that you will be getting 10 by root 2. 1 by root 2 is 0.707 into 10. So the correct answer is 7.07 ampere. This is how we are basically estimating the value of RMS value of the waveform. Fine sir. So now take this question as the homework question. Spend some time. If you don't get the answer, then don't try to ask anyone. Collect the formulas related to this. Substitute all those things. It is already available in your short notes. try to bring the answer by using the short notes. And apart from that, my sincere suggestion, இங்க நம்ம வந்து ஜஸ்ட் வந்து ஐ எம் கிவிங் தி பேசிக் லேஅவுட். இதை நம்ம எப்படி பண்ணலாம், ஒரு வே ஃபார்ம் கொடுத்தா அதுல இருந்து நம்ம வந்து எப்படி திங்ஸ் வந்து எக்ஸ்ப்ளோர் பண்றது, and I am bringing all other related things which are relevant to that particular question. What you guys need to do is practice as many questions as possible. அட்லீஸ்ட் நம்ம நடத்துறதுக்கு ரிலேட்டடாக இருக்க எல்லா கொஸ்டினையாச்சும் சால்வ் பண்ண ட்ரை பண்ணுங்க. சச் தட் இட் வில் பிகம் வெரி ஈஸி ஃபார் யூ இன் ஃபியூச்சர். ஸ்லோலி என்ன ஆகும் அப்படின்னா, நீங்க ட்ரை பண்ண ஒரு டைமுக்கு அப்புறம் ஒரு கான்செப்டை கத்துக்கிட்டா அதை நம்ம வந்து எப்படி வந்து அப்ளை பண்றோம் அப்படிங்கிற இதை வந்து உங்க மைண்ட் செட்டுக்கு வந்துடும். தென் யூ நோ நீட் ஆஃப் மை ஹெல்ப், யூ வில் பி ஏபிள் டு சால்வ் ஆல் கொஸ்டின்ஸ் பை யுவர் செல்ஃப். ஸோ ப்ராக்டிஸ் ஆஸ் மெனி கொஸ்டின்ஸ் ஆஸ் பாசிபிள். ஃபர்ஸ்ட் நியூமரிக்கல் கொஸ்டின்ஸை நிறைய சால்வ் பண்ணுங்க. அதுக்கப்புறம் என்ன ஆகும் அப்படின்னா, நியூமரிக்கல்ல நீங்க தியரி அண்டர்ஸ்டாண்ட் பண்ண ஆட்டோமேட்டிக்லி தியரிட்டிக்கல் கொஸ்டின்ஸ்க்கு உங்களால ஆன்சர் பண்ண முடியும். ஏதாச்சும் புதுசா பாத்தீங்கன்னா என்ன பண்ணணும், கீப் ஆல்வேஸ் ஷார்ட் நோட்ஸ் வித் யூ. புதுசா பார்த்தோன்னே ஐயோ இதை நான் படிக்கவே இல்லையா போச்சு, அப்ப நான் இதுக்கு இந்த மாதிரி நிறைய படிக்காத இருக்கு, நீங்க இந்த மாதிரி ஒரு கனவு வரும் நிறைய பேருக்கு. பேசிக்கலி என்ன ஆகும் அப்படின்னா, நம்ம என்னதான் சிலபஸ் வந்து கவர் பண்ணாலும் 90% தான் வந்து எல்லாருமே கவர் பண்ணுவாங்க. பிகாஸ் இட் இஸ் அன்னோயிங்லி ஹேப்பன். ஒரு சில விஷயங்கள்லாம் வந்து யாருக்குமே தெரியாது இந்த விஷயம்லாம் இதுல சிலபஸ்ல இருக்கு அப்படின்னு சொல்லிட்டு. அப்ப கொஸ்டின் எடுக்கிறவங்க என்ன பண்ணுவாங்க அப்படின்னா, அவங்களும் வந்து என்ன பண்ணுவாங்க, அந்த பர்டிகுலர் டாபிக்ல அதை பார்க்காத ஒரு சிலர் வந்து எடுத்துட்டு இருப்பாங்க டக்குன்னு. அந்த கொஸ்டினை பார்த்த உடனே நீங்க இந்த கொஸ்டின் நம்ம படிக்கல, இந்த கொஸ்டினோட கான்செப்ட் தெரியலன்னு உடனே அப்ப ரெக்டிஃபைல நம்ம பாதி படிக்கல அந்த மைண்ட் செட்டுக்கு வந்துருவீங்க. உடனே போயிட்டு எல்லாத்தையும் உட்காந்து பார்த்துட்டு இருப்பீங்க. தட் இஸ் ஆல்சோ ராங் அப்ரோச். வாட் யூ மஸ்ட் டூ இஸ் only take hint only for that particular question, what is the concept which is relevant to that particular concept question. அந்த மாதிரி இருக்கிறத மட்டும் பார்த்து அதை நோட் டவுன் பண்ணி வச்சுக்கோங்க ஷார்ட் நோட்ஸ்ல. 1 or 2% தான் மிஸ் ஆகும், எல்லாமே மிஸ் ஆகாது. ஸோ அந்த மாதிரி நோட் டவுன் பண்ணதுக்கு அப்புறம் என்ன ஆகும் அப்படின்னா, ஒரு 10-15 இடத்துல அந்த மாதிரி புதுசா பாக்குறீங்க அப்படின்னா என்டையர் சிலபஸை நீங்களே கவர் பண்ணிடுவீங்க மிஸ் ஆன போர்ஷனையும். Then you won't get any new things.